Hello students, welcome to Edubbey Global Solution. We're going to be looking at another topic in our mathematics class, which is further trigonometry. In our previous class, we considered sine curve, tangent curve, and cosine curve. Then we used Pythagoras theorems and the basic trigonometry ratios to solve examples. So in this class, we're going to be using a cosine rule and sine rule to solve problems. Okay, so now let's start with our class. Now the very first rule that we're going to be making use of is what? Is the sine rule. So the sine rule is a relationship which can be used with non-right angle triangle. You know, the previous class under the normal trigonometry, we consider basically right angle triangle. So sine rules are actually used for angles that are non-right angle triangle. And the rule states that A over sine A equals to B over sine B equals C over sine C. That is when you are calculating small angles. And you are calculating size rather. So if you are calculating angle, you can use alternatively sine A over A equals to sine B over B divided equals to sine C divided by C. Okay, now with that, we're going to be looking at this activity. The sine rule is a relationship which can be used with non-right angle triangle, which is true. We can't use it for a right angle triangle. Okay, so that is true. Now let's look at the class exercise that we are going to be solving together. Look at this triangle here. B, the capital B, that is angle B, is 30 degrees, while small b is 6 centimeter. A, the capital A is 40 degrees, while the small a, we don't have the small a. So we have to calculate for that side, which the side is what? BC. So we are calculating for small a. So if we are doing that, then we are going to be using the formula for calculating the length, which is you know, we are dealing with two sides here, so we can say that we have small a over sine A, okay, equals to small b, small letter b over sine b. Whereas small letter a we don't know, and capital letter A, which is 40 degrees, okay, and b is 6 centimeter, where the capital B is 30 degrees. So we cross multiply. So A we multiply sine 30 degrees, okay, while 6 centimeter we multiply sine 40 degrees. So sine 30 degrees is 0.5, so we have 0.5 for A equals to sine 40 degrees, okay, is 0.625. So we have 6 centimeter multiplied by 0.42 6428 428. That's how we might have approximate. So multiplying that by 6, we have 0.5 A equals to 3.8567. Okay, so if we have that, then we divide by 0.5, we divide both sides by 0.5. So we have A to be 0.5, we have A to be 7.7 centimeters. We have 7.71 centimeters, and that is the small a. Okay, so let's quickly put the right answer into the boxes and let's see what we have. Okay, so the sine rule says that A over sine A equals to small letter b over sine small letter b. So if we said that sine 60 multiplied by sine 30 multiplied by that is 0.6428. okay, so after we might have divided 3.856 divided by 0.5, we said that our A is 7.71 centimeters. So let's check our arrangement. We are right. Now let's look at another example under cosine rule. That is when you are looking for the angle itself. Okay, so here now we're going to be making use of angle. We have this, you see that we have angle A to be 60 degrees. We are calculating angle C, and we have side A to be 6 centimeters, side C to be 6.5. So under sine rule, the best formula for us to make use of is we have sine A, that is the capital letter A over small letter A equals to sine C, the capital letter C over small c. So sine A we have it to be 60 degrees already, okay, and we have small a to be 6 centimeters, how do we know it's 6 centimeters? Since that is adjacent the angle. Why sine C we don't have, and the spot C is 6.5. So we cross multiply. So we have sine 60, okay, multiplied by 6.5 equals to 6 centimeters multiplied by sine C. Okay, so if you want to get sine C, all we just need to do is what? We divide this 6 centimeters, we divide the other side to by 6 centimeters. So 6 centimeters we cancel each other. So we have sine 60 to be what? To be 0.8 0.8660 divided by 6 centimeters equals sine capital C. Okay, so if we have that, we have it to be 0.1443 equals to sine C. So since we want to get sine C, we find the arc sine. So we have arc sine 0.1443 equals to C now. So if we have arc sine, under your calculator, you are going to be pressing shift 0.146. Okay, so if we have that, then we are going to be having 0.69.8 raised by 0 as our answer, and that is the degree for C. Okay, so that gives us the solution for that problem. Okay, now let's look at another rule, okay, which is what? Which is cosine rule. The cosine rule is another relationship which can be used with non-right angle triangle. So for cosine rule as well, we can make use of right angle triangle. And the rule states that a square equals to b square plus c square minus 2bc cos a. That is if we are looking for a. So if we are looking for b, we interchange it to be b square equals to a square plus c square minus 2ac equals cos b. If you are looking for c, it's going to be c square equals to a square plus b square minus 2ab cos c. And that's how the rules goes. Okay, so with that, now let's look at the class activity that we have under that. But before then, let's look at this test of brain that we have. The cosine rule is another relationship which can be used for what? It can be used for non-right angle triangle. So we are right. Okay, now let's look at the activity that we want to solve. We have to calculate the length of side BC from this triangle. If you look at it, angle A is 50 degrees. We have a small a and small b is 9 centimeters. Small c is what? Small c is 7 centimeters. So I'm going to be making use of the cosine rule. So that implies that we are calculating for what? A. So we have it to be a square equals to b square, okay, plus c square, okay, minus 2bc cos what? We are looking for a, so we have cos a. So a, what is the small a? We don't have small a, so a square will be, what is b now? B is 9 centimeters square, okay, plus small c is 7 centimeters. Remember, we are having square centimeter square minus 2 times 9 times 7 multiplied by cos what is a? That is 50 degrees. So we have it to be that is 81, right? 9 times 9 will give us 81 centimeter. 7 square will give us what? That is 49 centimeter minus 2 times 9 times 7 will give us 126 multiplied by what? Multiplied by cos 50 degrees. So if we have that 81 plus 49, that is 130 centimeter minus cos 50 will give us 0. So we have 126 multiplied by 0.6428. So 0.6428 multiplied by 126 will give us 80. Okay, so we have 130 centimeter minus 80.99 centimeter. So we have 130 minus 80.99 centimeter. The answer is 49.01 centimeter. But remember, we have a square, so we are introducing square root so that we can cancel the square. So we cancel, we have a equals to, what is root 49.01? That is 7. So it's going to be 7.00 centimeters. So that implies that the small size A is 7 centimeters. So let's quickly fix the right hand side into the process. We are using the rule A square equals to B square plus C square minus B C multiplied by 2 cos A. Okay, so after that we said that cos 50 will give us 0.62 0.6428. Okay, now if you have that 126 multiplied by 0.626428 will give us 80.99. So 130 minus 80.99 will give us 49. Now the square root of 49 is 7 centimeter, and that gives us the solution to that problem. Okay, now let's look at area of a triangle. Now the normal formula for calculating the area of a triangle is what? We've treated that in our previous class. That is half base times height. Okay, so we have it to be half, that's normal area of a triangle, base times height. Now we said that sine theta is what? Sine theta is what? Is opposite over hypotenuse, isn't it? So if hypotenuse, so if opposite here, if you look at it, opposite in this direction is what? Is h. We are looking at this structure, this right angle triangle. Okay, so opposite is h, while our hypotenuse is a. So if that is the case, we can now say that if we want to make h the subject of the formula so that we can fix it in this right angle triangle, so we have it to be a multiplied by sine theta, okay, equals to what? Equals h. So that implies that now if you have this, wherever you see sine theta, wherever you see h, so instead of h, we are replacing it with a multiplied by sine theta. So our new formula for the area of the triangle having the right triangle in it is going to be half multiplied by base multiplied by a multiplied by sine theta, and that's the formula for area of a triangle having our right angle triangle divided into 8. Okay, now we want to look at short distance from a point to a line. We are going to be explaining this. It said in general the shortest distance from a point to a line is the distance measured perpendicularly to the line and passing through a point. So if you want to measure a short distance from a point on the line, the best thing for us to do is what? We draw a perpendicular line towards that line, and that is the shortest distance. So, and we are measuring the line through a what? Through a specific point. You can see the illustration here. This is the line x and y, and we have a point here which is point P. So we are drawing the perpendicular line to join x and y at O. So now we want to look at another subtopic here, which is trigonometry in 3 dimensions. Okay, so we have, let's look at what we have here. We have a cuboid, okay, a cube rather, and if you look at this cube, it is actually being divided. We have d to h is 3 centimeter, a to e as well is going to be 3 centimeter since it's 3 dimensions. So h to g 3 centimeter, g f 3 centimeter, b c we don't know, so we have to calculate e to g from here. So if you look at this sketch here, e to g is just like we are having a what? We are having a right angle triangle. Okay, so because look at the sketch, we sketch from here to here with what we have here, it's going to be a right angle triangle. So having that, and since we have 2 sides, then we are going to be making use of what? A Pythagoras theorem. Okay, which says that hypotenuse square equals to opposite square plus what? Plus adjacent square. So let's sketch out this drawing and let's see what we are going to be having. The drawing look like this. Okay. Okay, so if you look at this is more or less like a right angle triangle. So from here now we can say that that this side is 5 centimeter. Okay, so we have the other side to be what? The other side EH to be what? EH is 3 centimeter. What we are calculating 3 centimeter. Okay, HG also is 3 centimeter. So EH is 3 centimeter, HD is 3 centimeter. So we need to get EG. So we have EG square, that is hypotenuse square equals to opposite square, okay, plus adjacent square. So the opposite here is what? Is GH, okay, and the adjacent here is what? EH, okay, plus EH all square. So which is what? 3 centimeter, okay, plus what? 3 centimeter. Remember, we are putting it all square. We are putting it all square, okay? So we have it to be 3 centimeter all square. That is 3 times 3. That is 9 centimeter square plus 9 centimeter square, and that will give us 18 centimeter square. Remember, we are looking for EG and it has square, so we are introducing what? We are introducing square root, and that square root will cancel square. So we have it to be EG equals to root 18 centimeter. So because the square also will cancel each other. Okay, so if we have that, root 18 will give us 4.24 centimeters to the nearest two decimal point. Okay, so that gives us the answer to that given problem. Now let's look at angle between line and a point. The other time we look at distance between line and a point. So let's look at angle between line and a point. The angle between the line AB, you look at it, this is line AB and AC, okay, represent angle between the line AB and the shaded plane. Okay, so the line AC is a projection of line AB. So line AC is actually a projection of what? Of line AB on the shaded plane. So now with that, we're going to be looking at some past question. The first one here, look at this shape. It's divided into two equal triangle. Right now, we are now supposed to calculate what? We have to calculate angle ACD. Angle B is 123. Angle C is 32. Angle A is 25. So we are calculating what? Angle A, as is, we are looking at the other side of the angle A CD. So we are looking at this side. That is what we are calculating. Okay. So if that is it, then note that we have the small side. So small a, what is small a? Small a is going to be what? That is now 9 centimeter. Then the small b, since we are calculating C now, the small b is going to be small b is small g. We are using this situation is 14 kilometer, and small c is 9 kilometers. So what we are using here is going to be c square equals to a square, okay, plus d square, okay, minus ad, okay, cos, what are we looking for? Cos C, or we call it cos ACD, since that is the angle that we are looking for. We are looking for this point. So in this angle, small c is 9 kilometer all square, okay. Small a here is what? 12 kilometer all square, okay. Small d is what? 14 kilometer all square, okay. So now we have it to be minus 2 times 12 times 14 cos ACD. Now, if that is the case, 9 square will give us 81. Let's remember we have it 12 square, that is 12 times 12, that is 144 kilometers square. Okay, 14 square will give us 196 kilometers square. So 2 times 12 times 14, this is minus, times 14 will give us 336. Then we have cos ACD. Now, if we have that, okay, 144 plus 196 will give us 340, okay, minus 336 cos ACD, okay, equals to, we have 81 kilometers. So we bring 81 to the other side, we are subtracting. So 181 minus 340, because it's crossing the equation sign, so it changes to what? Minus, equals to 336. We have minus 336 cos ACD, okay. Now if that is the case, 81 minus 340 will give us minus 259, that's 259, okay, equals to minus 336 cos ACD. Okay, now if we have that, we are going to be dividing both sides by minus 336, since we are looking for what? Cos ACD, so we have minus 336. So minus will cancel each other. That is 336 will cancel 336 here. Minus will cancel 36 minus here rather. So 259 divided by 336 will give us 0.7619 approximated. Okay, so cos ACD. We want to get cos ACD, then we have to make it to be arc cos 0.7619. So we have arc cos 0.7619 equals to what? Angle ACD, and that will give us 40 degrees. So that implies that angle ACD here is what? Is 40 degrees. That's the solution to the problem. Let's look at the next one. Now, the other part there tells us that we should show that angle BC is 7.05 kilometer. Okay, so if we have to do that, let's look at it. We have how many sides there? We have side B. Okay, we have side A. Okay, so all we just need to do is we are going to be employing sine rule, since we are looking for what? We are looking for side BC, and we have two angles there. Okay, so if we are using sine rule, then let's make use of sine A, that is the capital A, since we are looking for side, over small a equals to sine B over small b. So if that is the case, sine A is what? Sine A, okay, here we are using that. Okay, we are looking at, so sine 123, since that is what we are having, equals to what? Sine 123 over 14 centimeter. B 123, we have 14 kilometer, equals to we have sine 25 degree. We don't have the angle yet. Look at this. We don't have this angle. This angle, we have this. So we have it divided by BC. So we cross multiply. So we have sine 123 degree multiplied by BC equals to sine 25 degree multiplied by 14 centimeter. So if we have that, sine 123 degree will give us what? It will give us 0.8389 approximated. So we have BC, since we are multiplying with BC. Sine 25 will give us 0.4226 approximated. We have multiplied by 14 centimeter. Okay, kilometer. Now we are using kilometer. Okay, so if that is the case, since we want to get BC here, we divide this side by 0.8389, divide the other side too by 0.8389. So we're cancelling each other. Then we have BC to be 0.426 multiplied by 14 will give us 5.9162 kilometer. Okay, divided by 0.8389. So if we divide that, then our line BC is going to give us 0.05 kilometer. And that's all the problem. This takes us to the end of the class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.